Right. I'm just going to give a short talk, more like a discussion about the various bits of security data that exist. And it's kind of similar to the CTX yesterday. There's a lot of concepts that really do they apply to open source, and why would we use this stuff? I mean, it's kind of frustrating that most of the security standards they seem to externalize someone's business model more than some sort of generic, interchange of information. Often, if you look at any of the standards, you're like, oh, where's all this complexity coming from, and why would a tiny little project, even though it's used a lot, like curl, have to go and do this? It takes energy, to maintain all these security artifacts. And are they doing anything for me? Or are we just doing good work for really huge companies that they can do this work by themselves? So what I thought might be nice is to just go through and just sort of prove out each one of these standards and see what it means to curl and why we might use them and why we might not use them, right? So the first one, CPEs. Everyone here know what a CPE is? Okay, so Common Platform Enumeration, I guess. And basically, in the world of computing, naming stuff is hard, so this is a name. We're trying to identify something. And the idea is that a global distributed planet-wide naming scheme like URIs might be useful to use this kind of thing, right? So they came up with this naming scheme. I think it was probably Red Hat who did this, or someone at Red Hat. I don't particularly like it. It's just matters of syntax and why would you do it this way. There's a million other ways to do it. I personally kind of think this is exposing a lot of information, and why would you squirrel away all these particular bits of metadata? The idea is that with these sort of coordinates, you can identify something, right? And also, what is this something? Like CPEs is, if you think about URIs once again, we like to type in domains instead of numbers, Why I can't remember the numbers, because the domain names are nice to remember. There's that sort of this sort of dual purpose, humans and machines. And the idea is that this would, for humans would be understandable, and I could use it. Anyways, people use it, and it turned out that they started abusing it. In other words, instead of when you talk about identity, there's some real basic things like, am I identifying one thing, one person, when I use this CPE? Is there overlap? Partially identifying some things, or is there aliases? Things got confused, and we came into a world where there's kind of lots of CPEs, and it kind of, I don't know if it was the realization of them or the implementation. Anyways, because of that, we got curls. Once again, if you're going to do a global, planet-wide distributed naming system, URIs are great, right? And once again, we're going to choose some stuff and squirrel it away into this string, and those coordinates will define everything for me. Once again, and unfortunately, the security standards, don't talk to each other. They don't learn from previous mistakes, and there's nothing wrong. I like package URLs. Perl is kind of a weird thing to say because it means something different for me. There's a lot of Perls out there.
Difficult name, right?
And it's this sort of overloading that I just can't, get over. But anyways, apart from the name, I kind of like these kind of ad hoc community standards because basically, you got a couple of engineers who are like, we got a problem. We got to identify stuff globally. Let's come up with a simple scheme for that, and let's do it. And they really didn't go into the astronautics of engineering and overcomplicating things and all that. But like every specification, there are some rough edges. I went a couple of months ago. We had a triage with the PURL people, and the first thing I did was I tried to create a EBNF to define their rules, and it was not possible. There are ways to make Perls that aren't valid URLs. And this to me is, like, this happens when you do specifications and standards and you don't have a contained thing. What, like, for example, what's happening now is there's probably Java libraries that do URL parsing that are being used for Perl, and then there's some weird gaps going on because of escaping rules here. There's always going to be warts on any approach. This one seems particularly egregious, but that's not a death knell. Basically what I want to show is between these two naming schemes, there's a real problem. I don't know if you can identify what the problem is, but it's sort of, I think these specs get made in terms of how you consume things. So maybe an engineer goes to DNF, says install curl, install libcurl, or install something. And they don't realize when they press a button, the package manager is sort of converting, is adding a lot of metadata behind the scenes. It's saying, right, what kind of operating system are you on? What architecture is going on? There's a lot of stuff going, and the end result of whatever happens on your machine, that bag of bits, is a lot more than just the name, yeah? And this is one of the problems, is that on one end of the scale, I want a nice short name, like the top one, cool, to tell me that's what I want, but that always means in context of something, yeah? That bag of bits on your machine will be different than the bag of bits that's on that machine. And what we have is we have sort of an approximate naming ID, yeah? It's always approximate. It's only concrete in a context. So when we talk about CPEs, it's sort of all over the place. Pearls are a little bit different because usually, well, the only time they are indeterminate and precise is when they are used within an SBOM, which provides enough context to say, I know how that was built, I know what dependencies it's in, and it was GCC was used, and it's completely, in theory, pinned and pegged in time and space, yeah? But if I take that Perl and I give it to you, without the SBOM, we have the same Perls. In lots of SBOMs, let's say in Red Hat, you'll see the same Perls. But one will be built with CLang, one will be built with GCC, one will be built with OpenSSL, one will be built with new TLS. One will be static, one will be dynamic. And what's the solution to it? Oh, we'll just add more URL parameters. It's like, that's once again, madness, once again. So most people, even in the security industry, they they don't really think about this that much. And then we have confusion later on in life. So I'm going to sort of tie together all these things at the end, but we're going to go through each one. Please fire away any questions. All right. CVEs. We all know what a CVE is, right? Curl uses CVEs. Yeah? We populate, every time we get a CVE, we populate it. Seems pretty straightforward. I think it's probable that it's an okay format. It does us service. Like it's a good metadata. It's not arduous in terms of a huge amount of work doing CVEs. And it seems to be pretty non-controversial in terms of maybe CVE format. This JSON is different than this XML is different than this text representation. CWEs, common weakness enumeration. I find it odd that we use CWEs, right? And they seem to provide value. It's a nice sort of buckets of, oh, this is in here. And I think it's because the CWEs are pretty well defined. They're kind of, and it's not millions of things. It's a nice constrained set, right? And we use it, and that's great. But CVSS. So what's the difference between this enumeration that we use and this other enumeration that we don't use? Why did this fail and CWE was successful? I think the CVSS it externalizes, like if you're a security engineer, this is what you'd like to come up with one number. And there's misusage. I mean, the implementation of CVSS, people have a number and they think that number is that's generically applicable. But we have problems all the time with NVD saying one CVSS and Red Hat is like, well, that's on Windows. It doesn't, it's zero for us basically, Or we never light up that code path, so it's never, we don't build curl with that option. So that's problem number one, is expectation. Having a number means something to everyone worldwide is just not possible because you need a context. A low CVE curl might be very low, but what if it's used in notifying the backup generator of a nuclear power plant to turn on, right? The context is really important. And CVSS has created a spec that says, oh wait, don't do that, don't just have a number, always make a local interpretation of your number. Yeah? But that begets a lot of work. And us,
it's not really used like that either. So.
It isn't used like that. And there's no amount of education we can do to fix that, right? So I don't want to say CVSS has failed, but I just think its applicability is just, I think the intent is good. There's always, end users want a number. Oh great, it's a 10, it's a 0, you know what I mean? But we have severity on CVEs, or impact, and I don't know how much more. There's psychological tests that say, usually humans can cope with 3 to 4 rankings or 5 at the most in terms of ranking. 0 to 10 is bad, 0 to 5 is good. And all this complexity, why do we have to externalize that? And why is the CEO talking to me about privileges required? Once again, it's like accountants hiding in their bank account codes special meaning. That what happens when it changes? Yeah, how do you update this type of thing? So we don't use Grill. I can't see a way of this system being changed so we would use it for value for us, right? The people I work with is like, it's understandable. A number becomes a proxy, and that proxy always fails over time in terms of what you're using the number for. And severity seems to be enough for us. It seems to be easy enough for us to agree on a high, critical, or low, right? Versus all that.
Yeah, that's hard enough. It's sometimes really difficult too. Right?
And that also has a contextual argument too. It might be that a UAF that causes a denial of service in a certain context could be life-threatening.
Yeah.
Some medical machine shuts off at the wrong time. Yeah.
Yeah. So Greg Hartman for the Linux kernel, then they don't even do that, right?
Yeah.
So because and their argument is quite fair that this assessment that we do to set the severity level, we do that primarily because we have a bug bounty based on this level, right? Because otherwise there would be little motivation for us to even go there. But they don't have that, so they don't even do that.
Right.
So if you run your code in a toaster or in a space rock, it's completely different sense, right? So is it important or not? It depends, right? Yeah.
Well, conversely, CVSS is probably included in support level agreements, like it's the same kind of pinning to something.
To something, yes.
And I think the answer of don't do anything is not an option in the commercial world. Yeah. So there's pressure in the commercial world to do something, to peg some baseline to stuff. But I can't see how we fix it, even with infinite amounts of education. I think the system as designed is just unworkable. And I'm not sure, across all ecosystems and all problems, I don't know what value it is to normalize a 9 here in Golang versus a 3 in Python versus it's.
I think, in my mind, the case is clear. There's so much money involved here in the usage of this, in running this and building systems, selling this to organizations and companies. So that's the value here. There's a lot of dollars on the numbers in the end. That's what drives this. So they want it to be there. Yeah. A lot of people want it to be there because it's a lot of money involved.
You're right. I kind of always think of good intent and. I'd rather live in my make believe world of is this a good idea? If it was a good idea, how would we do it? And yes, people are always going to make money out of stuff, yeah. And really, I mean, in the heat of battle at scale, all this stuff falls apart, right? It's just we don't have the time to argue. Well, even a small little project like us doesn't have the time to argue about CVSS. And what value does it give to us in the short term? None. Yeah. Right. SBOMs. Everyone knows what SBOMs are, right? I kind of think that like like we have build systems and they slough off all this metadata whilst you're building, and then you have the end result, which is the generated artifact. An SBOM can give you all of the transitive dependencies, how things are dependent on each other. They can give other stuff that's interesting to compliance people, like licenses, and copyright, or what cryptos are you using? What cryptology algorithms you're using. And other dependency relationships, there are important upstream relationships that you want to annotate. At Red Hat, we like to know when we have a source RPM and its relationship to all the binaries. We like to know upstream relationships. We like to know, with container land, you have another set of tree-like relationships for base containers all the way down to a million containers down.
I watched a talk from Fosden about metadata in SBOMs, and it's crazy.
Well, and once again,
everyone defines their own metadata, like the EU, the US, India, financial services, like every country in the world comes up with their own metadata keys for SBOMs. Plus you have like this company own things you want to track there. So it's like, it's not just like 10 meta pieces in there, it's just grows and grows and grows.
Yes.
And this overloading, like if this happened to Oval, this happened to every format out there, the security industry just blows it up and it makes it unworkable. SBOMs, really, from my point of view, are just like at a minimum level. You could do this transitive dependencies plus other dependencies, other relationships. It's important to know who was upstream. It's important to know containers. There are other graph-like relationships beyond transitive dependencies that are interesting. The licenses stuff, the copyright, the other business metadata, it's just crazy. Absolutely crazy. But software is going to get sold on that. AI bombs, AI software, by the way. It's all. I kind of like for curl. What does it mean to us? Now, at the moment, we don't use SBOMs, but we have the other problem that C projects. We generally don't have package management. Yeah, so like a lot of the other ecosystems out there, like Rust with Cargo, Python with pip, all these come with a lock file that then you can generate most of what an SBOM is pretty easily. For us to generate it, well, let's use a package manager. I'm like, no, let's not do that. That's dumb. We're not going to go use Conan. There was a nice FOSDEM talk in 2022 with a tool called CD bin tool, and maybe it'd be useful to take a look at the output of that. I have something running here. Oh, that's me. One moment. Other glasses. I think I have this somewhere. Bear with me. There we go. Right, so so I ran that tool against, the curl source, and I generated. There's also different formats. It's different serializations of SBOM. So there's SPDX and CDX, Cyclone DX, and it generates something. What does it generate? Okay, top level. It's this document. It comes up with the library hacks. It says the CPE. We use GCC to compile it. libcurl.
I kind of like how they did that, put the hacks in the CPEs.
I'm doing this to show what the view of curl is from other tools, which is kind of not very useful. And there's a section with dependencies, so that gives you transitive dependencies. Anyways, it's very short and it's very inaccurate, and it doesn't tell anyone anything. So there's a sort of horizon of knowledge in the security world, and a lot of tools. And people push buttons, and they get the information they want. So if you're using a certain ecosystem like Rust or or Python or any of the other languages, you're getting a beautiful SBOM with everything. Well, with C projects, you're getting nothing. So it's like a shell script living in the world of compliance. So what do we do with a shell script? There's no license, and so basically C projects and curl are blind spots in all of this massive being sold software. And you know what happens to blind spots? People who buy software, it's like, why are we doing this in C? Yeah, it's an adoption factor that maybe the engineer doesn't have any control over, and lawyer guy would go, oh, it'd be better if you did this in Rust because I get beautiful SBOMs out of this, and I can right. That's not the excuse. That's not the reason why engineers should use SBOMs. SBOMs in their minimal form can be useful. Yeah, just like at Red Hat before SBOMs, we had build systems, and they generated huge amounts of metadata for every build, hundreds of thousands of builds, and that was proto SBOM. Yeah, it's good. You go to Debian, you see what a package is built, you get all this metadata. That's useful for us engineers, right? I can go to Debian and look at the configure flags for curl that's included, right? That's useful for us, and SBOMs can do all that, right? SBOMs in that instance as a tool for engineers is just about interchange. Yeah, it's not about me exchanging my giant enterprise business metadata model and whatever. But right now, most of the tools that are out there are blind to C projects and curl. Oh, sorry, I could do this because, oh no, that's, yeah. Okay. All right. Right. So we don't generate SBOMs. And yeah, maybe there are tools out there. If I put the curl container, like there's now tools that'll generate an SBOM from a container. Yeah. So it'll generate all the dependencies and all of the stuff that's in there. Actually, because they're like I generate like curl the container, we build a static thing. We don't. So it's blind. You can't get inside of it. And there are lots and lots of tools that people are using. Here's one which I generated on the curl. See what we got for reports. SBOM. Yeah. So it's this was the best I could do. But this was a whole container with it, so that actually is not very useful. So one moment, that was too much, because it's just the information about the actual thing. Here's the curl source code. So none of these are good, by the way. Don't go use FOSSA. Okay, so here we go. Here's the SBOM Here's the SBOM from the tool. You get that big tool you bought a lot of money for, and you're going through all the stuff on your machines and your thing. And curl is basically a blind spot. Yeah.
Yeah. Relationships.
Curl is curl.
Curl is curl.
Yep.
And that's the way but that opaqueness is going to be a pressure of non-adoption. Yeah. Because new person coming out of college gets in a seat, says start programming, push this button when you want to generate the SBOM, or SBOMs are generated as part of the pipelines of these people, and the manager will come up and is like, why are you using curl? It's not, there's no. So what do we do as a small project? Oh, let's generate SBOMs. It's like, no, let's not do that. But, and this isn't like a big reveal. I was thinking the other day that maybe we could consider, and I haven't done any code for this, but actually we do generate SBOMs. Huh? How do we generate them? It's just a non-standard proto SBOM.
Build dash version.
No, we use the curl config tool. Yeah, the curl config tool is actually, if I run curl config and I run all these flags, I could probably make an SBOM out of all that stuff, right? And the thing is that we are doing it, but we're doing it just in a non-standard way. So maybe a small, tiny little step would just have a serialization of the information we have here into a SBOM, right? And then that means that all the tools, anywhere where anyone's built curl config, could have their SBOM, just in a format for interchange, not in a minimal thing. So I didn't have enough time. I wanted to sort of write a transformation from this stuff to here, but I just wanted to ask, would that be something, a very small step that might give curl a bit more exposure? Is that something you can consider? No? Don't know.
I mean, sure, why not? I mean, we can try it out and see what the interest is, right? So,
I mean,
that's also fairly lightweight and sort of non-intrusive to everyone who doesn't care.
Yeah, the other thing too is that SBOMs are weird. They're theoretical on one level. Is that SBOM the runtime of what's going on right now? Like we have work going on in Red Hat. We have telemetry coming from people's running systems, and there's JVM stuff. And the idea was, you could take the JVM and generate a SBOM from the actual stuff that's running. But a lot of times SBOMs are aspirational, theoretical. Like the software that is running and installed may not have actually installed this one dependency. Yeah, it may have done something different. So there's this sort of sliding scale between truth and reality. This is actually pretty close to the truth, yeah, because it's exactly what's running, what's been built.
How do SBOMs manage dependencies to shared libraries?
Yeah, well, once again, runtime SBOMs are different than like a build SBOM. Yeah. So most people, when they're talking about SBOMs, they're talking about build SBOMs. Yeah. Actual runtime SBOMs we're not there yet. Yeah.
Okay.
But that is on the horizon. That will be coming soon in terms of. Oh wait, we didn't really like. People thought their first step was the right step. It's like, no, this is just like you're opening your eyes and getting more in focus. That's all that's happening. Yeah. Yeah.
All right.
Yeah. So. So out of all those specs, I mean, this one is Vex. How many people know what Vex is? Yeah. So if you're like a scanner vendor, like you have a scanner that finds vulnerabilities, you used to do it a whole bunch of hacky ways to get the definition of of how to identify some vulnerability or vulnerable component on your system. And now the idea is Vex is going to be used for interchange. So all scanner vendors can pull down all these definitions, and then they can find bad component. Similarly, we can generate, people who are writing advisories, which we don't, you could generate in this format, and there's lots of tools out there for using this kind of interchange. I think this is out of scope for curl. I think the CVE system we do now serves most of the double duty for everything. I don't think we need to go one level up to advisory. And one of the reasons why is that Vex isn't about, you can represent like a single or multiple products, single or multiple versions, single or multiple CVE, single or multiple statuses. That is, I've sent out an advisory, we fixed this, but we haven't fixed this yet, and relations between it. All that complexity is not, what's the worth for us? Yeah, we just generally fix it in the next release. Yeah, it's not like Red Hat has, if there's a vulnerability in a compression library, we have to respin up the entire universe. Yeah, we have to build every container, we have to build every bit of software, and this is a complex, big bad problem. And you could see that something like this for interchange is better for scale, but I don't think curl. We have churl, we have wcurl, we have curl. It seems to be not useful. So, there are other standards, yeah, but I don't think they're worth discussing unless people think of one and you want to talk about it. I can tell you why we shouldn't do it, but there are other standards other than specifications like security.txt, well-known URI that might be nice to have on the website.
We do.
Oh, well, there you go. So they're small.
I even have a nice, because the security.txt thing, it has an expire date in it, which is super annoying because it's the same info. I don't want an expiry, so I have a little cron job that updates it every once in a while to 6 months into the future, whatever. Because it's also it's sort of not permitted to have it too long into the future. So it's automatic.
It's a dead man's. It's a dead man's point. Yeah.
So as long as it's not shut down, it'll sort of be fine.
So there's another thing that's relevant to kernel, OSV, which is...
Yeah, well, OSV is, once again, there's a lot of aggregators out there. And actually, the software that I helped write is sort of is like an OSV for Red Hat internally, and we've just released it. So I'm very familiar with them. So you could go to 10 different places to get CVs, or you could go to a one-stop shop like OSV that has everyone's pushing all their CVE definitions to OSV now, and VEX as well. Yeah, so you get advisories going there as well. And the idea is VEX modulo CVEs. You have the complete picture. To you can tell all the vulnerabilities and the status of all things and what you should fix first. A CVE all by itself doesn't tell the whole story. An advisory will tell you the whole story in the context. So what about it? Yeah. Okay. So it shows. Should we push our CVEs to OSV? We do already. They already pick them all up.
Yeah, I think we do.
In general, for a lot of open source projects, they've already captured everything. Yeah.
So OSV.dev, I don't think exposes the curl OSV.
Okay, maybe that.
Yeah, so maybe we can push them. Yeah. We push all ours, like all of Red Hat stuff on a asynchronous basis. We're pushing into this data. There's probably a Red Hat. Yeah, there's a Red Hat. Actually, I think we might be the most CVEs there now. Can't remember. So we go into Red Hat. Oh, what am I doing here? Oh, right there.
Ecosystems.
Yeah. Okay. So 2 days ago. So this is advisories. So RHSA is an advisory. It tells you all sorts of stuff, and this is a machine thing. So it's telling us Thunderbird's got a problem. That's the affected package. It tells us the range, and there'll be a relation to the upstream, and that will either that goes to either there'll be an NVD or a Red Hat definition, which might be different. Yeah. So this avoids you having to scrape everywhere, basically, for all this information. Yeah, we should. I think maybe it's already there. Let me just do a search.
When we started publishing those in OSV format,
yeah, if
the
it's
whole idea was to be pulled into there.
Yeah, well, they'll pick up everything from NVD. So if we go to any of the curl vulnerabilities, that's disclosure. I'm always get a little.
Yeah, curl CVs on the right side there.
Right side there. Thank you. So if we pick up the last one, I'll just search for it. It'll be there, I'm sure. All right, so all that is getting picked up automatically, anyways. So that's good. That's great. And so
look, they even link our JSON thing there.
Yeah. So, this is the idea. Like, a lot of these formats. One of the mistakes they make is that they think they're making a data model, and actually you're making an interchange model. All these formats are about data movement between one system and another. You're not don't take that data model and then make it the center core data model internally. Yeah. Mm-hmm. SBOMs are just a mechanism by which we can share. CVEs are just a mechanism by which we can share. Our systems about CVEs are a lot bigger than just these details, and they'll have a lot of business metadata that no one in the world would ever care about. You know what I mean? We have workflows that no one would care about, like all this stuff that doesn't need to be exposed by the data models. So we're already participating unknowingly everywhere. But I think, out of everything I looked at, out of all these, I think we're, maybe with CPE we could provide something a bit more canonical. We could look at what tools generate CPEs from our stuff and maybe get rid of hacks, for example. Be a bit more current. Pearls, okay, so Red Hat has a lot of libcurl pearls. We mint them ourselves. But it'd be nice to have an upstream Perl, base Perl, yeah? I don't know if that should be github.com/curl, but it'd be nice to tell people what's the invariant upstream Perl, yeah, that you should use. CVEs, we already do that. Vex, we shouldn't do. CVSS, I didn't even put on here because there's really no point for us. But I think the SBOM stuff.
Regarding that CVSS, I just wanted to mention that. So, since when we don't add it, someone else adds it, right? So that's why it ends up so super crazy all the time. And the ones who are adding it, they have no idea. They're just rolling the dice, and we get something super crazy. And that's evident. It's not sort of just me making it up. And they clearly don't know what they're doing. It just happens to be that. And again, they all want it. It's not a mandatory field, but apparently it is mandatory anyway, in effect. So now we're working, so within the OSS CNA work group that we have, we're working on a proposal to make to forbid CISA to populate that field if we don't populate it. Basically making sure that no one else adds that field if we don't add it. I think that is actually a good thing if it will happen. And I know, again, the Linux kernel, the Perl, the actual Perl project, not with an E, not a U. They have the same issue, right? They don't know in which context the stuff is used. So setting a score is really
fraud.
Yeah, that's not possible.
Yeah.
So having CISA adding the score really just ruins everything for us.
Yeah.
So I think it's an interesting development. We'll see how that goes.
Well, so I tried it with Gemini to generate one, but it's time horizon can't get to it. Yeah, so we can try an older one. Like this is what's happening now. People are using their GWiz, sorry.
It's too new.
Yeah, and they, the automatic so let's take an older one so we get past the horizon. No. Generate CVSS for. Whoop. See what it comes up with. Anyways, yeah, the value. I think the value for us is low doing CVSS. But what's going to happen is people are going to assign us CVSS scores if we like it or not, in one way or another. I think the CNAs, there's a, there we go. So let's see what we feel about that. CVSS 3.1 score of 3.4 low. Yeah?
Yeah, that seems fair. I think it was set low in there. Yeah.
So tools are going to happen, and regardless, computers make everything worse. Yeah. But if it's good enough, people are just going to do it. Yeah. And if 9 times out of 10 that gets the correct CVSS score, it's going to happen. Yeah. One way we could do it is we could just not generate it and just give them this prompt and say what, we don't have to say it to people, but you can generate it yourself. Like we could just push it off and say we will never assign a CVSS score. Be really explicit about that.
I think that's the only sensible way.
Yeah.
Because, as you say, everyone is always going to mess things up anyway.
Yeah.
So it doesn't really matter. Whatever we do, someone is going to mess up in the other end. But we don't need to be sort of complicit and participate in that stupidity. We can just sort of say no. And then you go ahead, you can still mess things up. That's fine, because that's what the world does, right? But we don't have to be part of that. And I think when CISA and the likes sort of puts those scores into the CVE ecosystem, it looks like we participate, and that's what I am mostly against. in the end, I mean, if we don't provide it, of course the vulnerability scanners and the likes, they will add it anyway. But then it's on them. And it's like when users are, for Red Hat, Red Hat sets their own scores. And I think that's fine. That's the correct way to do it. Everyone assess their own sort of vulnerability for us, for our products, for our customers. That's the right way to do it, because then you have context, then you know something, then you add that and you get a good, then you have the potential to get a decent score. I don't think it's sort of, so the scores will remain there. I'm sure the world loves scores and a single dimension sort of severity, 0 to 10. It's so attractive to everyone, so we won't get away from that. But we can at least try to not be complicit.
And I think it's totally reasonable. You know, the one thing I would like to do is I'd like to have a go with the SBOM stuff. I think there's some value in that we already do this in a non-standard way. It's a kind of really small step to generate an SPDX or a Cyclone DX of JSON version of the information we have already.
But based on what?
In curl config.
So yes, curl config is something that you do after you build the curl. Or
Yeah, that's good.
yeah, but we don't build the curl.
No, sorry. Curl config, when you, sorry, I thought curl config was generated.
It is.
It is.
Yeah, I thought it is.
Configure and CD.
Yeah, by configure. So
If
you get,
once you configured.
yeah,
Once it's run, it's generated by configure.
Yeah.
And CMake.
yeah.
Yeah.
Yeah, but it's done so it knows the build.
It knows. It might not know all the build information. It might have to be enhanced a little bit to be a bit more finer grained.
So,
And also, you're never going to know runtime. Yeah, you're never going to know.
No, exactly. That's just the
well,
build.
we don't know that anyways, and people like.
So what you're talking about is not that we ship an SBOM, but that we ship a tool that generates an SBOM.
Yeah, we just put a
Based
flag
on
on
what the user
curl
configured.
config. Yeah, we just put a new flag on curl config and say generate.
Yeah, output the same data in a different way.
Okay.
So
Okay.
the SPDX tool can actually generate an SBOM, but based on the source code, and it will generate an SPDX format, basically including license information, all the source code information, which useful for some people, less good for others. And Victor also pointed out that a lot of the information that's missing from curl config is available in the build info text file.
Yeah.
So that could
be combined.
We can, but you know, we have to be careful that is not leaking information that we don't want beyond build. Yeah.
Right.
It's generated by the user, so the
Yeah,
user can
yeah.
leave all they want.
But I think we can enhance curl config and we can just do a simple SBOM and then we go jump double. Yeah. Because everyone who has curl that's been built can generate an SBOM, and now they're not blind in all these toolings. You know, that's useless. Because with C projects, you need the compiler to tell you all these things, and they're not going to do that. They're going to want to introspect off the source code. It's just crazy the stuff that's going on. It's like, why are you using LLMs to figure all this stuff out? You could just run GCC and know it.
So we could ship the SPDX file with the source code already if we wanted to.
Yeah.
But it's so easy to generate that
Yeah.
almost isn't.
It'd be a nice stamp too. I think for curl container, we could ship the SBOM and we could put it as part of the repository. You could see it. It could be in the reproducible. Well, I don't know what we don't necessarily build curl. We have a reproducible build, but we don't. For Debians of the world, they might like that. The ability to make a standard. Don't know. Anyways, all this does is a small little step to let curl be more visible in the world that is emerging. And I think it's not that much pain. Yeah, I'd like to. I'd like to have a go at it, but I wanted to sort of pass by you guys if you thought it was.
Yeah, my personal emotional objection to this is that the SBOM seems to be dominantly important for the commercial world of software, and it's just another freely delivered piece into the commercial engine that never gives back, basically. So I'm just like, why should we do also this for free?
So I would counter that. I would say SBOM, the specification is free. We're already doing build information. Debian, everyone's doing build information. All we're doing is coming up with a standard way of doing it instead of Apple's way of doing it, Debian way of doing it. and interchange. Everything else, I agree with you. I think, are we making it easier for companies? Probably. Is that a bad thing? No, we're making it easier for companies in a lot of different ways. How much pain is it for us? What's the risk of having, maintaining this little thing? I kind of feel it's weighed off by the blindness of all these tools that are happening. I know what happens to, like all the little shell scripts, basically they just go away, you know? Like lawyers are like, what's that there, what's that? You know, it just becomes a real blind spot in developer tooling or pipelines and all this type of stuff. And this just makes it dead easy, you know? Right, that's all I have.
Thank you.
Thank you.
Thank you.